Welcome back. We're now going to talk about how to solve a literal equation. That's that second piece or second objective that's part of our first standard. And a literal equation is an equation that has multiple variables in it, and you are going to be solving to get one of the variables by itself. Okay, so we're not solving here to say x equals a number. We are solving it out to see what happens when I try to get a variable by itself. Now, the biggest application to this is when we are graphing. Throughout the year, you are going to need to make sure that y is by itself before we graph it, because that's the only way that our graphing calculator can understand how to graph. So we're practicing this skill now to make sure that we are ready to be able to use our graphing calculators later in the year. So the first problem wants us to be able to get y by itself. Well, I see one y and it's trapped inside of these parentheses, so we have to break it free by multiplying the 2 out. So I have 2x plus 2y, recopying everything else. Now we can just use those same inverse operations we were doing before in solving to be able to get this literal equation to have y by itself. So I'm going to subtract 2x from both sides. Now, lo and behold, our 2x's are gone. And I'm left with just 2y minus z equals z. So let's add z to both sides. We're trying really hard to get this y to be by itself. And when I do that, I have 2y equals now 2z. We're going to divide by 2 on both sides. And that leaves me with just y equals z. I will tell you 99% of the time it will not solve out to be something so simple as one variable equals another variable. It just so happened that it did it in this problem. It may also be helpful for you to take a different color or even just your pencil and kind of put a box or a circle around the variable that you're trying to get by itself. Number one, when you do that originally, you can see how many there are, so you know you'll have to combine like terms later. And number two, it just kind of helps focus your idea. So when you distribute that 2 out, you can kind of focus that, okay, everything else needs to go away, and I know that addition and subtraction has to happen before I can do anything else when I'm trying to solve. Let's take a look at another one here. We are now trying to solve for r. So in this problem, I will go ahead and circle that variable for you that we're trying to get by itself. And notice I just want the r, I don't want the square. Well, when you're solving an equation, remember you're working those order of operations in reverse. So we are first looking, and there's nothing to add or subtract, but there is something that's already being multiplied. So I can get rid of this 4 and the pi all at once. They're right now 4 times pi times r, so we're dividing. And it's okay to go ahead and write them both together. As a matter of fact, I think it's actually going to be less confusing for you to go ahead and divide both the 4 and the pi together so that you don't somehow confuse what happens when you already have a number in the denominator and you're dividing. So we're left with s over 4 pi equals r squared. Now we just want the r, we don't want the square. The opposite of squaring something would be square root. So we are going to square root both sides, which means that r would equal the square root of s over 4 pi. Now technically, in math, whenever we square root both sides in an equation, we want to add a plus or minus. I would technically be okay with this one not having it because you may recognize that that is actually a formula from geometry, and we know that radius really wouldn't be able to be negative here, so plus or minus wouldn't necessarily make sense if we identified that as a formula. But it's always a good idea to recall that when we do square root both sides, we want to put a plus or minus 99% of the time. Let's take a look at our next problem. Gotta move it up a little. Number 3, we are now trying to get r all by itself. I only have the one r. That makes my life really easy. Working those order of operations in reverse. I need to get rid of that p that's being added. It may be helpful to you as well to kind of think about, well, what if all of the other variables were numbers? What would I do next to get that r by itself? And if this said 2 plus something, you would know that you would have to subtract 2 from both sides. Whatever you need to do to think about it. So there's that r stuck in the middle, but it's stuck in the middle of kind of a multiplication sandwich there. So to get rid of multiplication, we divide, and just like on our previous problem, it is totally 100% okay to divide by p and t at the same time. So I have a minus p over pt. Now be very careful. You may not cancel out those p's, because what's really happening over here is I have a that's over p and t subtracted by p over p and t. So if I were to just cancel out the p's here, I would be changing the problem because this fraction would no longer have a p underneath it. Now, if you do choose to write it like this, it is a lot easier that I can keep going and actually simplify a little bit more. I could simplify this down to just a over pt minus, and these p's cancel because there's no addition or subtraction here that would force it into two fractions. So I'm left with just 1 over t equals r. If I'm being completely transparent, which I try to be, I would accept this one or this one, either one, because with all of those variables in there, it gets a little messy. Now, if we're dealing with just x and y, and we're solving for y, I do always want you to simplify because there's some other numbers in there, and we want to simplify that before we go and start to try to graph things later, which the rest of our problems here pretty much deal with just x and y, except for maybe 7 and 8. So let's take a look. Number 4, I need to solve this for y. So that means the first thing we're checking out is, are there addition and subtraction signs I got to get rid of? And there are, so we're going to subtract x from both sides, leaving me with 180 minus x, and it equals 2y. Then we need to divide by 2 on both sides. Now remember, this is something that I need to actually separate out and simplify. So I have 180 divided by 2, and I have x divided by 2. Can you simplify 180 over 2? You absolutely can. It's 90. And I'm just going to get a little picky here. We like to write our x term first so that it looks like something in slope-intercept form that you may have graphed in Algebra 1. So I've got a negative 1x over 2, which I can rewrite as negative 1 over 2x, and a positive 90. Again, if you don't understand kind of what's going on with the simplifying, start this problem. I can go through it with you the next day when you're either virtual or in person. Let's take a look at number 5. We are once more solving for y, but this time y is trapped up on top. And I know that you might see an addition or subtraction sign there, but that 7 is trapped on top first with the y. So we are not able to just add 7 to both sides. You've got that fraction. And remember, like I said in the previous lesson, when you have a fraction, it's mostly a good idea to go ahead and multiply by that denominator and get rid of it. So we're going to multiply by x on both sides, giving me y minus 7 equals 11x. Now we can add 7 to both sides. $11x, because I like my x term first, and then a positive 7. No need to simplify here. How about number 6? We're trying to get that y by itself. I've got some addition and subtraction to get rid of, so I'm going to add 6x to both sides. Just a reminder, we don't combine it with the 12 because it doesn't have an x. So I have 2y equals, and I like my x term first, so 6x, and it's a positive 12. Now, if writing it like this there you go. If writing it like this will either confuse you or you'll forget to write it as two separates to simplify, I have a solution for you. Whenever you are dividing, go ahead and just immediately divide by each term on the other side. And actually, that's probably what I do 99% of the time. I go ahead and when I see two separate terms, terms are separated by addition and subtraction signs. So I see a 6x and a 12. I go ahead and divide by the 6x, or divide in the 6x and divide into the 12. So I'm left with y equals 6 over 2, 3x, 12 over 2, I gave you the answer there, which gives you 6. Let's take a look at 2 more. This one, we are trying to solve for a. Now, one of the number one mistakes I see is people try to divide by m on both sides and say that a equals p over m. That's not actually true. That a is stuck in the denominator. So even if you divided by m on both sides, you would still have 1 over a left. So that's not what we want. We're going to go back to that kind of mantra I've been repeating a couple times, which is if I see a fraction and something I need is stuck in that fraction, I'm going to multiply by the denominator. So I'm multiplying by a on both sides. It's one of the rare occasions that what you are actually looking for, which is the a, will be moved to the other side. So I'm left with AP equals just m. Now I can actually take and divide by p on both sides. I was apparently too quiet. My lights shut off in my room. So I'm going to give it a second to kind of refocus there. But the p will cancel out, leaving me with a, and it equals m over p. Number 8. We are now actually solving for x. So we're not solving for y, we're solving for x. So I'm going to subtract my y first. So I have x times k equals u minus y. And to get x alone, I have to divide by k on both sides. So x equals, and again, I'm okay with leaving it just like this because there's not a bunch of numbers there, but you could also write this as u over k minus y over k. I'd accept either one. When we're dealing with just the variables, I tend to just leave it as one big fraction. It looks prettier in my mind. All right, go ahead and take out your assignment, try some of those problems, and check your answers on Schoology.